Welcome to The Explainer. Today we're jumping into one of the biggest challenges in tech and honestly, in business. How do we make sense of the messy, chaotic world of documents? How do we unlock all that critical information that's just trapped inside them? To see how we get there, we really have to start with one fundamental question.
And I mean, really think about this question. We're not just talking about scanning words on a page. We're talking about truly understanding meaning, context, relationships, the way a person does. The chase for this goal, well, it's driving a massive technological shift right now.
But okay, before we can even get to the amazing solution, we first have to appreciate the sheer scale of the problem we're trying to solve. And trust me, it is a big one.
I mean, just think about it for a second. Written language? It's an incredible human technology. But for a computer, a contract or a research paper is basically just a jumble of unstructured data. The whole challenge is figuring out how to translate that jumble into something a machine can actually use to make decisions.
And you can see just how complex this gets. It's not just about the words and the punctuation. We have to deal with documents that are over 600 pages long, and you might have simple little paragraphs sitting right next to these insane tables with thousands of rows. Every single one of these things is a unique hurdle for a machine to understand.
And here's where it gets even more complicated. The most valuable stuff, the real insights, they don't come from looking at just one file by itself. Nope. They come from understanding this intricate web of connections between all the documents. How does this invoice relate to that purchase order? How does one patent build on another? That's where the real gold is hidden.
For decades, we have been trying to solve this puzzle. But the tools we had, they weren't up to the task. They always fell short.
So the classic tool for this job has always been optical character recognition, or OCR. And its job is pretty straightforward. It looks at a picture of a document and translates the shapes it sees into digital text. It's a really crucial first step, but it's only a first step.
See, the problem is that OCR is brittle. It can give you this giant wall of text, but it has no real understanding of what any of those words actually mean. It gets totally tripped up by complex tables or weird page breaks, and it has absolutely no idea how one document connects to another. It can see the letters, but it completely misses the story.
To make smart decisions, you have to understand these document hierarchies. So take this example of a vertical or parent-child relationship. You've got a master service agreement, that's the parent. It spawns a child, the statement of work, which then leads to a grandchild, the invoice. If you want to understand that invoice, you have to understand the entire family tree.
But hey, it's not just about those vertical relationships. There are also horizontal or peer relationships. Think about research papers that cite each other, which then leads to a patent, which then informs the product documentation. It's this complex network of ideas, and the old tech just couldn't map it out.
So if all the old tools couldn't get the job done, what changed? Well, the breakthrough came from a completely new kind of model, one that could finally understand language itself.
And this is the absolute game changer, the large language model, or LLM. It's built on this incredibly powerful foundation called a transformer architecture. And an LLM isn't just programmed with a bunch of rules. No, it's pre-trained on these massive data sets of text, which allows it to actually learn the patterns, the nuances, and the context of human language.
The scale of these models is just mind-boggling. Instead of just recognizing characters, they use hundreds of billions of parameters to learn the mathematical relationships between words. So they don't just see the word king, they actually understand its statistical relationship to queen and royalty and power. It's pretty incredible.
Now, the way this all works is completely counterintuitive. You might think that finding the important facts in a huge document is all about whittling it down, right? A reductionist process. But the reality is the exact opposite. It's all about a massive expansion first, and then a contraction. Let's just walk through that real quick. Imagine you start with a single document. We'll say it's just 1,000 words.
So when you apply an LLM, that one document just explodes into over 10 million new data points. That's the system analyzing every single possible relationship and meaning it can find.
And it's only after that massive expansion that the system can then contract all of that analysis, collapsing it down to maybe the 50 key insights you actually need. It literally has to understand everything just to tell you the most important things. Okay, so an LLM gives us the raw intelligence, right? The ability to understand. But you still need a dedicated workforce to actually go and perform all the tasks. And that, my friends, is where AI agents come in.
Just think of these like a digital assembly line of specialists. You've got an inspection agent making sure a file is even valid. The OCR agent does that initial text conversion. Then comes this crucial step, a vectorize agent, which converts words into numbers, creating that mathematical meaning the LLM can work with. After that, an extract agent pulls out the key data, and a match agent pieces it all together, building out those complex document hierarchies. Each one is a vital part of the process.
And here's the really cool part. When you put all of these agents together, you don't just have a faster process, you have a fundamentally new way of processing information altogether.
This right here represents a huge shift in thinking. We're moving away from these old, rigid, linear pipelines where, step 1 has to finish before step 2 can even start. We're moving toward these new agentic workflows, and they're autonomous and dynamic. Agents can be triggered by events like a new file just showing up, and they can all interact with each other to get the job done in the smartest, most efficient way.
This is so much more than just a simple speed upgrade. By creating a system that isn't locked into some rigid, predictable path, we enter what's called a non-deterministic space. And what that means is the system can potentially discover insights and connections all on its own, opening up possibilities that we, the human operators, might never have even thought to look for.
And that leaves us with a final and pretty provocative thought. For decades, we've been trying to understand our data. We are now building systems where the data can begin to understand itself. So what new discoveries, what new efficiencies, what new ideas will emerge from that? Well, the possibilities are really just beginning to unfold.